This is Chapter 1, Section 4, Key Math Skills for Chemistry. As I mentioned before, you've all passed the prerequisites for this course, so I'm not going to spend too much time on any of these slides. It's really more of a reminder about what math skills you should be comfortable with. Here we start with the basics such as numerical place value, ones, tens, hundreds, tenths, hundredths, etc. For example, what is the place value for the underlined digit in this number? The first place to the right of the decimal is tenths, and the next one, where the underlined 7 is hundredths. You should understand positive and negative numbers and how to use them in mathematical expressions. For instance, two negative signs cancel out when multiplied or divided, and so on. I'll assume you're able to add and subtract with negative numbers. Here are some more examples. Here you can see a picture of a typical scientific calculator. One thing you should be careful about is that on most calculators, the minus key for subtraction is different from the key for turning a number negative. Here are some examples of how you would enter a typical expression on a calculator like this. Since there is such a wide variety of calculators on the market, I'm not going to take up any time on this. Percentages are an important concept for this course that sometimes trip people up. The word percent comes from the Latin phrase for by the 100. So the essential thing to remember is that a percentage tells you how many parts you have out of 100 total units. What usually confuses people, though, is figuring out what the 100 total units refers to. If you're asked to calculate a percentage, it's pretty straightforward. Take the number of parts, divide it by the total number, and then multiply it by 100. For example, if 8 out of the 32 books on my shelf are about chemistry, you take the 8, which is the part, and divide it by 32, the total, to come up with 1/4, or 0.25, as the fraction of books that are about chemistry. Multiply that by 100, and you find that 25% of the books are about chemistry. In cases where you're given a percentage, on the other hand, you can assume that the total is 100. For instance, if you know that 20% of the gumballs in a gumball machine are red, what does this really mean? You may not know how many gumballs are actually in the machine in total, but you do know that for every 100 gumballs there are, 20 of them will be red. Solving algebraic equations is another extremely important skill for this course. The algebra we need won't usually be that difficult, but it's crucial for you to be able to solve an equation like this relatively quickly. Every second you waste trying to remember how to cross multiply is a second you don't have to figure out the chemistry involved. This example is taken right from the chapter on gases. This equation is called Boyle's law, and it tells you how the temperature and pressure of a gas are related. In many problems, you'll need to start from an equation like this and solve for one of the variables. So how do you solve this for P1? This is a simple example. To get P1 on its own, you need to get rid of that V1. Since they're multiplied together, you have to divide by V1 to cancel it out. Then remember that anything you do to one side, you also have to do to the other side. Last but not least, you'll need to understand how to interpret graphs. Most graphs that we encounter will represent a relationship between two measured variables plotted on two perpendicular axes. The horizontal or x-axis tells you the value of one variable, and the vertical or y-axis tells you the other. Usually, a graph will have a title that tells you what variables are being shown. If there's no title, the axis labels can help you figure it out. In this case, the volume of a gas is plotted against its temperature. The points on a graph represent pairs of data values, one for each variable. If you think about your personal experience with balloons, it should be clear to you that you can control the temperature and the volume will change as a result. The convention for graphs is that the variable you control, the independent variable, is on the x-axis, and the variable that changes as a result, the dependent variable, is on the y-axis. And finally, the data points in a graph are usually connected by a line or a smooth curve. The line helps reinforce the relationship between the variables. In this case, it's a direct relationship. As you increase the temperature, the volume also increases, and so the line has a positive upward slope. But the line or curve also helps fill in the gaps between data points. It allows you to predict what value the dependent variable will take at a given value of the independent variable without doing additional experiments.